Welcome to Inquisitive Kids. In this video, we'll be introducing the concept of rational equations. This is part 1 in our lesson, Discovering Rational Equations. Parts 2 and 3 will be coming up soon, so be sure to hit the notification bell as well as the subscribe button. Anyways, this will be the last lesson we're covering in this playlist. So the two learning goals of today is to understand the concept of rational equations and to master the basic ideas and solutions of rational equations. Write down rational equations according to the information given in a problem. So here is our introduction. There's a word problem. 2 points A and B are 1,400 kilometers away from each other. Taking a high-speed train from A to B takes 9 hours less than taking an express train. The average speed of a high-speed train is 2.8 times that of an express train. So you're being asked 3 questions. Find all of the equivalent relationships in this problem. If the average speed of the express train is set to be x kilometers per hour, what equation does x satisfy? And if Karen takes a high-speed train to get from A to B, it will take her y hours. What kind of equation would y satisfy? Now, in order to solve these, we need to go over the distance, speed, and time formula. So remember, that is distance is equal to speed or velocity times time. This is the formula that we are using here. Writing rational equations for word problems. This is our first question. So this is the same question that we had in our introduction. What are all of the equivalent relationships in this question? Well, there are 2 of them. The first one is that the express train minus 9, and that the high-speed train speed is 2.8 times that of the speed of the express train. If the average speed of the express train is set to be x kilometers per hour, what equation would x satisfy? Well, to answer that question, the equation would be 1,400 over x minus 1,400 over 2.8x is equal to 9. If Karen takes a high-speed train to get from A to B, it will take her y hours. What kind of equation would y satisfy? Well, the answer would be 1,400 over y is equal to 2.8 times 1,400 over y plus 9. So when you're being asked what kind of equation a variable satisfies, it's just saying, using the information given in the problem, how can you write an equation that contains this variable? Now we're given another word problem. In order to help rebuild homes in areas hit by natural disasters, a school is calling on its students to make voluntary donations. It is known that the total amount of donations from the first time was $4,800, and the total amount of donations for the second time was $5,000. There are 20 more people for the second time, and they each donated the same amount of money. If the number of people donating the first time is x, what kind of equation should x satisfy? Now I want you to analyze the word problem one sentence by one sentence and then break it down into its equivalent relationships. And then use those equivalent relationships to write an equation that includes x. So this is what your solution should have looked like. 4,800 over x is equal to 5,000 over x plus 20. From the previous problems, we obtained 3 equations. What similarities do they all have? So from the previous problems, we gained these 3 equations. Well, observing them, we can see that they all have variables on their denominators. Knowledge key point. Here is the concept of rational equations. It's an equation with a variable on the denominator. And here are the characteristics of rational equations. It must be an equation, there are denominators in the equation, and that the denominators contain variables. So determine which of the following are whole or rational equations. Now pause the video and I want you to categorize them. Well, 2x plus x minus 1 over 5 is equal to 10 would be a whole expression since it does not have a variable on the denominator. This would be a rational equation because it does have a variable on the denominator. This would also be a rational equation for the same reason. So, here is our method conclusion. A rational equation has a variable on the denominator. And notice that pi is a constant. So for this example here, a lot of people might think that pi is a variable, but it's just a symbol that represents a constant number. Example 1. Which of the following are rational and whole equations? So I want you to identify which ones are rational, which ones are whole. Well, all we have to do is refer back to the definition. Numbers 2 and 3 are rational equations. Numbers 1, 4, and 6 are whole equations. And number 6 is not an equation because there is no sign. Notice, to determine, we can check the denominators for variables. For example, in example 4, pi is not a variable. The speed of a ship in still water is 20 kilometers per hour. The time it takes to sail 100 kilometers downstream along the river is equal to the time it takes to sail 60 kilometers upstream. So here I'm going to put upstream. So what would be the current speed or the water speed? So this is a classic ships on water problem. We actually did make a playlist explaining problems just like this because this is a special variation of an itinerary word problem. And we actually have made videos in a playlist talking just about this type of problem. So I will be linking that in the description down below for anyone who is interested. So here is your solution. We can first set the water speed as a variable, v kilometers per hour. So this gives us the equation 100 over 20 plus v is equal to 60 over 20 minus v. So, combining questions 1 and 2, what do we find in common between listing rational equations and linear equations for word problems? Well, we see that the steps are basically all the same. You start with finding the equivalent relationships and setting the variables, and then you write an equation based off of that. Finally, you have to solve the equation. So here is our conclusion. Here are the steps of listing rational equations. We first examine the information given in the problem and set the variables. And then, by finding the equivalent relationships in the problem, we can write down the rational equations for us to solve. Class summary. Today we learned all about rational equations. The concept is an equation with a variable in the denominator, and that is called a rational equation. And here are the steps of listing rational equations for word problems. We first set the variables, and then we use equivalent relationships found in the problem to list the rational equations. Today we understood the concept of rational equations and we mastered the basic ideas and solutions of rational equations. We also wrote rational equations according to the information given in the problem. Again, for anyone who is interested in itinerary word problems or ships on water word problems, I will be including the link to that playlist in the description down below for anyone who is interested. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.